Example G of lesson 4 is really just kind of a preview of what shows up in geometry when we have to solve by square roots. I think this should be the next lesson we get into, but this is the structure of the Pythagorean theorem, and if that is not even almost ringing a bell, then just wait till the notes tomorrow and then we'll go over it. But it's just saying that something squared plus something squared equals something else squared. So yes, we will have to solve by square roots because I have something being squared, but I don't have to deal with everything else being squared. I know what 5 squared is. Remember, squaring means to multiply something by itself. 5 times 5 is 25. So I'm going to go ahead and simplify those exponents and write them as just constants. So x squared plus 25 is equal to 0. So now I'm going to do the same process. I'm going to try and get my variable to the second power on its own. And I'm going to do that by subtracting 25. So 100 minus 25 is 75. And now that I have the squared term on its own, I'm going to cancel that. The opposite of squaring something is to square root. 75 is not a perfect square, so I will have to break it apart, but I'm going to go ahead and remind myself I'm going to get 2 solutions so I don't forget later. So 75 can be broken up because it's 25 times 3. And 25 is 5 times 5. So I have all my prime numbers. Instead of the square root of 75, I have the square root of 3 times 5 times 5. And since pairs make perfect squares, I see this pair of 5s. Since 5 times 5 is 25, I can go ahead and say that the square root of 25 is just regular number 5. And since nobody paired up with 3, there's still a square root 3 in the radical. And so my solution is plus or minus 5 root 3. So not really that different, just if you can simplify something, do that at the beginning to make your life easier. Otherwise, what you cannot do is 10 squared minus 5 squared and just say, oh, well 10 minus 5 is 5, so that equals 5 squared. 100 minus 25 is not going to equal 25, so do not do that. They're not like terms. So let's look at H. Kind of similar, kind of different. I do see something that can be simplified right away, this 8 squared, so I'm going to do that. I'm just going to rewrite the left-hand side. I'm going to notice that there's an x squared term, so I'm going to try and get that quadratic on its own. And I'm going to go ahead and say 8 squared is 64. So to start getting my variable on its own, I'm going to get rid of that positive 16 first. I'm going to do that by subtraction. 64 minus 16 is a number that I'm not currently doing in my head, 48. And now I cannot square root until the coefficient is dealt with. Now that coefficient is multiplication. So I'm going to solve by division, which gets me x squared is 24. I don't want x squared, I want x. So the opposite of squaring is to square root. And that gets me my 2 solutions, both a positive and a negative. And 24, I need to break it up so I can find my simplest radical form. 2 and a 12, 3 and a 4, and I'm going to keep going until I find all those prime numbers. So instead of the square root of 24, that's the same thing as the square root of 2 times 2 times 2 times 3. Pairs make perfect squares. This is actually a 4, and so I can go ahead and say, well, the square root of 4 is just the number 2. And inside the radical is my 2 times 3, so I've got a square root 6. Our solution would be plus or minus 2 square root 6. Part I is similar enough to part G. I'm going to go ahead and put that on this video too, because again, it looks weird. Something squared plus something squared equals something else squared. This is a preview of the Pythagorean theorem. Again, we'll talk about it more tomorrow, but I'm just going to go ahead and simplify the numbers. I know that 2 squared is the number 4. So this left-hand side is 4 plus 4 equaling x squared. And I can simplify that too. I can combine my like terms and say that 8 is the same thing as x squared. So now it's a lot easier because we're already at the end of it where I'm going to solve by square roots because that's the opposite of squaring a number. And I am going to get plus or minus this radical, but 8's not a perfect square. So I'm going to break it apart. I'm getting a 2, and a 2, and a 2. So instead of the square root of 8, we actually have the square root of 2 times 2 times 2. Pairs make perfect squares. So the square root of 4 is a regular 2. Inside the radical is still the root 2. So my final solution would be both plus and minus 2 square root 2. We'll pick the, are we? Yeah, we'll do a couple more in the next video.